Hello and welcome to a new video on IGCSE Classified Physics Paper 2. In this video, we shall be discussing the concept of fuses and hazards. So in this question, it says, in the circuit shown, only one of the fuses has blown, but none of the lamps is lit. Which fuse has blown? So this requires some circuit analysis. Now, if this guy blows out, what happens to the current? So let's assume the current is moving in this direction. It doesn't really matter. If this is blown out, there is no path here. There is an open circuit here. So it looks like this. So there is no path for the current to move here. However, there is a path for the current to move on the right. So what will happen is the current will continue to flow normally on the right branch, and it will move normally all the way back. So actually, all the lamps will light up if I remove D. So D is definitely not the correct answer. If I remove B, if I remove this fuse here, then this will be an open circuit. So the lamp here will not light up because there is no current, but the current will flow through C normally, whether up or down, depending on the direction of the current. It will be able to flow through C normally, and therefore will flow this way, and then that way, and then back to the power supply. So here in this case, the lamp beneath A will light up, the lamp beneath C will light up, the lamp here at D will light up as well. Only the lamp at B does not light up. So of course, this is the wrong answer as well. Similarly, if we remove fuse C, all the lamps will light up except for the lamp beneath C. The only fuse that if we remove, we stop the current entirely is fuse A, because here the current will move and then it will find a gap. There is no place for it to go. So the current will not even flow through the circuit at all. So if fuse A blows, there is no current in the entire circuit, and none of the lamps will be lit. A domestic circuit includes a 30 ampere fuse. This protects the wiring if there is too much current in the circuit. In which wire is the 30 ampere fuse positioned, and what does it do when it operates? Of course, this is something you need to know, that we place the fuse in the live wire. And it does not reduce the current, it disconnects the circuit entirely. So the correct choice here would be choice A. We place the fuse in the live wire and it breaks the circuit. In which diagram, a fuse is used to protect an electrical circuit. Which diagram shows where the fuse should be connected? Like we said, we connect the fuse in the live wire and in series, not in parallel. So these are both wrong because it's not connected in the live wire. For B, it's connected in parallel, which accomplishes absolutely nothing. The correct way to connect a fuse is diagram A, in the live wire and normally in series with the circuit. Two electrical appliances are connected to the main supply. The cable connected to one appliance includes an earth wire. The cable connected to the second appliance does not need an earth wire. What is the reason for this? So why do we need an earth wire? We need an earth wire for the following reason. If I have a toaster oven, for example, made of a metal or with a metallic casing, we say, if it has a metal case and the live wire accidentally touches the metal case, we can suffer from electrocution. We would get electrified if we touch the metal case. So we need to connect an earth wire that would carry the excess charges to the earth, to the ground, so that if we touch the metal case, we would not get electrocuted. So the simple reason is the second appliance does not need an earth wire because it does not have a metal case. The earth wire protects devices that have a metal case, or actually protects us from devices that have a metal case. So the correct choice here would be choice A. An electric kettle has a metal casing. The cable for the kettle contains a wire that is connected to the earth. Which danger does this guard against? This is exactly what we were speaking about in the previous question. The metal casing protects us from the case where the live wire touches, the earth wire protects us from the case where the live wire touches the metal casing. So why do we need an earth wire? To protect against the live wire touching the casing of the kettle. Or in other words, to protect us from the casing of the kettle becoming live. An electric washing machine is protected by an earth wire. To which part of the washing machine should the earth wire be connected? Like we said, the earth wire protects us from the metal casing. So we need to connect it to the metal casing to allow excess charges to flow to the earth. Why is a fuse used in an electrical circuit? To prevent the current from becoming too large. The idea of a fuse is that if the current becomes too large, you get an open circuit and no current flows at all. And why is this important? Because a very large current will cause overheating of wires, and this might lead to fires in a house. So this is why fuses or circuit breakers are very important. An electric kettle has a metal casing. The cable for the kettle contains a wire that is connected to the earth pin. Which danger does this guard against? Like we said, earth wires protect us from the casing of the kettle becoming live. So the correct choice here is choice B. Two electrical appliances are connected to the mains. The cable connected to one appliance includes an earth wire. The cable connected to the second does not need an earth wire. Like we said before, not needing an earth wire is attributed to not having a metal case, because the earth wire protects us from the metal case becoming live. So the correct choice here would be choice A. An appliance is connected to a mains supply. Its circuit also contains a switch and a fuse. Which circuit shows the fuse in the correct position? We mentioned before that the fuse should be connected in series with the live wire. So the correct choice here is choice C. Either a fuse or a circuit breaker can be used to protect electrical cables from large currents that could cause overheating. When a fuse is used, where should it be connected? And when a circuit breaker is used, where should it be connected? Fuse and a circuit breaker pretty much do the same thing. The circuit breaker might be just more accurate and might have a faster response, but they're pretty much the same thing and they have the same functionality. And we said they should be connected in series with the live wire. So X and X. The correct choice here would be choice A. A circuit breaker is designed to protect a circuit which usually carries a current of 2 amperes. The time taken to break the circuit depends on the current as shown in the graph. What happens when the current in the circuit is 2 amperes, and what happens when the current is 18 amperes? So if the circuit usually carries a current of 2 amperes, obviously we do not want the fuse or the circuit breaker to work if the current is 2, because then every day the circuit breaker would break the circuit or the fuse would blow. So if the normal current is 2 ampere, then we definitely want the fuse to not work until the current exceeds 2 ampere by a significant amount. So when the current is 2 ampere, ideally the circuit does not break. But when the current is 18 ampere, which is much higher, the circuit breaks in less than 0.01 seconds. And you can see this from the graph as well. At 2 amperes, pretty much nothing happens, right? The time taken to break the circuit is huge. It's very large. There's no circuit breaking occurring at all. But at 18 amperes, the time is almost zero. It's less than 0.01 seconds. And this is the proper functioning of a circuit breaker. In normal circumstances, it should work. The circuit should not break. The electricity should be allowed to flow. But In case of a very large current, we want the circuit to break quickly to protect us from overheating of wires. So the correct choice here would be choice C. And this brings us to the end of our video. Thank you for watching. I hope this was beneficial to you.